This is DANL100, Programming for Data Analytics. Chapter 2, Simple R Functions. Agenda. In this short video, I'll discuss the following 3 topics. Topic number 1, the simplest R function. Double any input values. Topic number 2, input values. Method 1, the meaning of input variable is based on its order. Method 2, according to the keywords. C, add default values for input variables and function without any input. Topic number 3, from one line code to multiple line code. We use a pair of curly brackets, and we can add comments. Since this is about chapter 2, then we can issue one line code. HTTP data_yy.com rpy week1 txt, and rpy, R for R program, py for Python. So this is rpy week1. C1 for chapter 1, so C2 for chapter 2. Okay. So we are going to discuss the simplest function, and I'm going to show you how to write the present value of one given future cash flow, present value of one future cash flow. Then I'll discuss how to input the values. Okay, the first one is the simplest one. Okay, so dd equals function and x, 2x. Okay, 2x. This is the simplest function I can think about. dd is a function name, so we can use any name. You can call double. If you want triple, or triple is not 2, it's 3. And equals, and the function is keyword. So function, and the value of variable inside a pair of parentheses is input variables. Okay, we can, for this case, we only have one input variable. In the future, we might have multiple. Okay, and the last one is output. We simply double it. So dd and 2, and we got 4, and we use up arrow key. Suppose it's 4.9, then we get 9. Okay, I think probably this is the simplest one line R function. Okay, in the future, in the couple of minutes, I'll show you how to write many one line R function. So this is the simplest R function. Function name and equal and keywords and input value and output value. Topic number 2. How can we write? First, we write one line R function. Then we extend it to multiple lines. Okay. So let's look at the present value function for one given future flow. Okay, it's 6. So dot C46. Sorry, dot C26. Okay, and so this is a function. This is a function name. A future value divided by 1 plus r with power to n. Okay, and so we can. Okay, so this is present value function, And again, you can use your own name. And again, so this is keywords, future value, R, N. We have 3 input value, future value R and N. Output with future value divided by 1 plus R, the power of N. Okay, so this is our function. And because it is one line, so we have function name. So this on the left hand side is function name. And this is keywords. Anything between these parentheses, they are input variable, and the last part is output value. Okay, so basic idea is, suppose we receive $100 in 2 years. It is if the annual interest rate is 10%, what is equivalent present value? So this is present value F, and 100 with 10% and 2. I repeat, the present value function is simply calculate equivalent present value for a given future value if we know the interest rate, and also interest rate or discount rate, and also how many number of period. Okay, and $100 period rate is 10% for 2 period. Its equivalent is $82.64. Okay. For a one-line function, we can type directly. However, it's a good idea we use some editor. Okay, I'm going to introduce 2 editors here. Okay, the first one is we click File. We click File. It's in the new script. Then we enter present value function. Okay, here equals function and future value R and future value divided by 1 plus R power N. Okay. Then we can just file and save. Okay. Suppose I save at C10, and I can put test. Extension is R. Okay, so test and save it. Okay, so this is one way we use our editor. Another way I use Notepad. Okay, the beauty of Notepad, because I'm teaching this course, I'm going to, you see the font, I can make it relatively bigger. Okay, the present value function. This is function. Okay, future value R N. Okay, future value divided by 1 plus R, and the power is N. So we have one line, very simple one line function. And again, so we have 3 input value, future value R and N. Okay, and I'm going to save it, and I'm going to save at C10. So let's call it present value function dot R. Okay, present value function dot R. And if we want, so let's remove present value function. Okay, let's remove it, and we can use source C temp present value function. Then we can activate. Okay, I'm going to remove everything. Okay, nothing here. Then I'm going to use up arrow key to activate my function. Okay, the present value function 100.1 and 1. Okay, then we get 2. Okay, so my question is, what is the meaning of 100? And obviously 100 is corresponding to future value. Why? Because it's the first input. Suppose we enter 0.1 and 100. If we reverse the order, the first 0.1, this is not interest rate. It is 10 cents. It is the future value. It's still the future value. So the second input is present value. Okay, the second input is interest rate. Last one is nominal period. Okay, and for this one, we call it method 1 because input value crucially depend on its order. Okay, so let's look at the second method. The second method is with R equals 10%. Future value equals 100 and equals 2. Okay, so let's compare. Okay, so this is, okay, this one, we input the value according to order. We don't have to specify the keyword. Okay, but this is method 2. So this is based on the keyword. So this is based on keywords, and because we have the keyword, okay, and n equals 2. So this is method 1. If we don't have the keywords, and then the meaning of each input depends on its order. Okay, if we have the keywords, then the order does not play a role. Okay, I think the mixed one is, suppose I have used this one. Okay, so this is mixed method. Okay, usually I will not introduce this mixed method. You can read my chapters. Okay, and again, when we input the data, we have 3 methods. And most important is method 1 according to order, method 2 according to the keyword. Okay, the beauty of the second method is, suppose another program wrote a similar function. Okay, so we have 2 functions. We get exact the same result. So let's save it, and so let's solve. And if you look at it, so we have 2 functions. Okay, so if we enter first one, and for second one, okay, because I know it has different order. Okay. What is R future value in? This is function 2. Okay, so this is function 1, this is function 2. We have get the exact same result. However, this input, we have the different order. Why? Because for the second function, the first is interest rate, the second is future value. Okay, how to avoid this issue? Okay, is we enter future value and R, and if we use keyword approach, okay, it really doesn't matter. Okay, if we use a keyword approach, you see, because we enter the same keywords, it doesn't matter what kind of order you have. Okay, and the beauty of this method, keyword approach, is we have same result. Okay, we don't have to consider the order. Okay. Below we have 2-line function. Okay. 2-line function we save at pb_f.r, and we can use source temp pvf dot r. Okay. This is equivalent to copy and paste. Okay. So if we want to see, and we can use echo equals true. This is exactly like we copy and paste to our R console. Next one, we are going to discuss default value. Okay. So let's go back to this function. Okay, we don't need this one. So let's delete it. And so this is a function. Suppose we type present value function. Okay. We didn't enter any value. It will give us an error message. And future value is missing with no default. Okay. The default value is simply mean we can enter, suppose 100. Interest rate is 10%. And now the period is 1. So these three are default values. So let's save it. And then let's activate. Okay. So this is our function. Okay. If we type our function, we'll see the future value. The default value is 100. Interest rate is 10% and equals 1. Okay. Suppose we call it so $80 and $80 and 5% and 2. Then this works exactly same as before. Suppose we don't have any values, and this is equivalent to 100.1 and 1. Okay, and even we can adjust it. Suppose this is 400, so 400. We use 400. You see the 400, 10% 1. If we didn't enter the next two input variable 2 and input variable 3, because we don't have the last two, default value will be used. Okay. And the advantage of set up a default value, we see less error message. The disadvantage of using a default value, sometimes they simply forgot what might be the default value. They enter some value, but they don't realize they're actually using default value. Okay. In the future, when we know the if function, then we can, so if the user uses default function, then the function should give a warning message or remind the user you are using default value. Okay. So this is about. Now let's discuss topic number 3. How to extend one line R code to multiple lines. Okay. We still use the same function to calculate the present value of one future cash flow. Okay. So this is one line. So let's save it. Then we can activate and present value F. So let's echo equals true. Okay, so we know this is one line. Okay, let's go back to make it one line, and we add a curly bracket and another. Sometimes our function don't need any input. Okay, and so let's try like hello. Okay, so let's hi function. Okay, we don't have any input. We simply print hi. That's it. Okay, so if we type, this is slow, print PR. Okay, so suppose we have a function called hi. Hi equals function and with no input, we print hi. Okay, if we enter hi, then it will echo hi. this is one example. Second example is, remember here, we type exit, and there's no function called exit. Okay, if we enter Q, okay, is Q mean quit, so let's cancel it. Actually, we can exit equals function. Okay, exit is equivalent to Q left, right, parentheses. So if we type, then it will be equivalent to Q left, right, parentheses. Change. Okay, we got $90.91. Okay, and then we add double quotation and another double quotation. Okay, as I mentioned, we have two ways. So this is comment. Okay, so we use a number sign. Anything after number sign, this is one type of comment. Okay, the second one is double quotation mark and another double quotation mark. Okay, so let's save it, and then we can activate. Actually, there's no material change. Okay. Now the most important thing is we add objective. Calculate the present value of one given future. Actually, we should have plural. Okay, and then so this is objective. I'm going to mention why I add an S here. Okay, and future value. So this is future value. R, period rate or discount rate, and the number of period. Okay. Also we can add the function. Okay, the formula. The formula equals the formula will be future value divided by 1 plus R, and power is n. Okay, so this is the formula. I'm going to make font a little bit smaller. Okay, I'm going to. Okay, as I mentioned, we have example number 1. Suppose we have like 4 example, okay, and with double quotation with, okay, I'm not going to change this one. And example number 1, number 3, number 4, and example number 1, and we just calculate here. Okay, and we can simply copy and paste. Okay, then we add some comments is based on the order. Okay, the meaning of input based on the order. 100 will be the present value because, future value, because future value is the first input. Okay, then we can use present value function. Okay, so this is R equals 10%, N equals 2, and future value equals 100. Then we get the same result. And I deliberately choose the same value. Okay, so this is, I call based on the keyword. Okay, another one is so-called, I'm going to save it. And another one called is, Suppose we have rate equals, we have 10%, 5%, and 2%, and 1%. Suppose we have 1, 2, 3, 4. We have 4 different discount rate. Okay, then we calculate present value. So this is rate. We have 4 different results. Okay, then we treat this one as example number 3. Okay, so this is example number 3. And we mentioned specifically one input is a vector. Okay, one input is a vector. Okay, so let's make them nice. Okay. Okay, another one I want to mention is, suppose we enter present value equal this one. Okay, return present value. Okay. Now I complete my function. Okay, I repeat. Okay, from one line function, and we add curly bracket and curly bracket. We make it multiple line. Okay, multiple line. Then we add this part as, you see, I can cut it. Then only 2 lines. Okay, so let's undo it. So all these comments I treat it as help. Okay, in the future, the user don't need our explanation. They can simply understand it. So let's use source. Okay. Oh, I use double quotation somewhere. Objective formula. Future value. Okay, let's see. Okay, so this so let's type present value function here. So if we type present value function, you'll see it will tell us objective of this function and what is the formula used and definition of input variable, and also 3 examples. Okay, example 1 based on the order, example 2 based on the keywords. One of factor can be a vector. Okay, the last thing I want to mention is we add a return. Okay, why we add a return? It is a good programming practice. For our function, we always have a return, so we know exactly which value our program return. Okay, another beauty of return is sometimes, suppose we have a long program, we have 50 line program, we can add a return at the very beginning. We know exactly, suppose we put it here. So we report it here, we return the future value. Okay, so if we put a return here, this 2 line, it will never reach. So let's save it. So let's active my code. And then if we call the function, okay, it will call function because we enter 100, it will return 100. Okay. So let's go back to code, and so we can use return to debug our long program. Suppose we have 50 at beginning, we output, we print the input variable. Then on the first step, we return the first intermediate value, and second step, we return the second intermediate value and until we reach the bottom of the code. Okay, sorry, bottom of the program. Okay, and you see this is a present value. Present value is a local. It's a local variable. Okay, so let's save it. So let's pursue. Okay, we are going to activate our program. Okay, so let's present value function, right? 100, 1%, 1. Okay, if we type present value, okay, present value, because for this code, the present value function is a local variable. What does it mean, local variable? Local variable is valid only within a function. Okay, so this is our function. Okay, so this is bracket, curly bracket. Within the function, after it's generated, it's valid. Okay, otherwise we cannot accept PV. Okay, how to make it global? So we use this. Okay, I'm going to put here. Now, because we use less than this one, okay, so after we use this way, this assignment, present value becomes a global variable. A global variable suggests we can access the PV from anywhere within our programs. Okay, so let's call it. Let's call this function. Let's activate first the present value function. So let's view it. Okay, so this is less than hyphen. The PV is a global variable. Okay, again, there's absolute no meaning of this one. So 100 and 1, 2. So let's use 2. Okay, now we can access PV, and for this example, there's no meaning to design PV as global variable. However, we can use this global variable to debug our program. Suppose we have, as I mentioned, we can use return different intermediate values. Actually, we can make intermediate value as global variable. Then we can look at the value of this value. We can look at their value after our program stopped.
Shutterstock Music.
Oh.